Okay, so this is we're going to do section H10F, chain rule. So in your textbook, they gave you this function. They want you to sketch it and determine the minimum. So what I did, in order to make this sketch, um, simply type in the function here, x to the power 4 minus 5x cubed minus 4x squared plus 20. Okay, and then I've already got a scale here that's going to help us. So we're going to hit window, and I'm going to change my x min max. I guess that's fine. The y min, I'm going to make that negative 140. And my y max, I'm going to make 100. And let's see the graph. And it looks something like this. So one of the ways, in order to draw a sketch of this, you can go second graph, and then I can see values. And so at negative 2, I'm at 60. I put a dot there. At negative 1, I'm at 22. Put a dot somewhere around there. At 0, I'm 20, and so on. So I used second graph to get me a table to get me some points to plot this. Okay, so in order to figure out the minimum, if I've got my graph, do second trace, go over to 3, I hit minimum. We need to do our left bound, enter. We do our right bound, enter. It says guess, we hit enter, and of course our minimum is 4.2 comma negative 109.85. Okay, so we've got our minimum at this point here. And what is the slope of this point? So the slope is 0, because at this point it's a minimum. So over here, the slope to the left of the point, you can see the slope is pointing down. It's got a negative slope. To the right of this point, you can see the slope is positive. Okay, so if I go from a negative slope to a positive slope, at that point here at the minimum, we've got a slope of 0. This should be reviewed from last year when we did our introduction to derivatives. So what is the derivative of the function? So from last year, we learned how to do the power law, which basically says this power here, x to the 4th, comes to the front and then decreases by 1. So we have 4x cubed. This 3 comes to the front and gets multiplied by the 5. So 3 times 5 is 15. And this power decreases by 1. This 4x squared, the 2 gets multiplied by the 8, and the power decreases by 1, so it's just x. And this 20, the derivative of a constant number, is 0. So there is our derivative. Okay, so what does the derivative function tell you? So the derivative function tells you the slope at any particular point on a function. So if I took the derivative at this point, if I took the derivative at this point, if I took the derivative at this point, the derivative gives you the slope at a particular point. Okay. So here is the formula for power law, and so if I plug in 3.5 into my function, I get a negative value. If I point 5.5, I get a positive value. So, and this is into the derivative formula. Okay, so what is the relationship between the gradient of the curve and the sign of the derivative? So this is a review from last time we taught this. So if the gradient is negative, that means the sign of the derivative is negative. Okay, if the gradient is positive, that means the sign of the derivative is positive. And it also means we've got a positive slope. Okay. I hope this is good review. Hope you remember this. Okay. Now, this is where people really this is important review. Okay, so find the equation of the tangent line for this function at point when x equals 3. So the first thing we need to do is take the derivative. So using the power law, the 2 gets multiplied by the 2 in the front, and the power decreases by 1. So there's my derivative. Okay, so now I need to figure the derivative when x is 3. So I'm going to plug in 3 in place of x, and then I have 4 times 3, and then I get 12. So that means my slope is 12. That means m is equal to 12. Okay? And I also, when x is 3, I need to figure out the y value. So to figure out the y value, I'm going to plug in 3 into my original function. So we have 2 times 3 squared minus 4. 2 times 3 squared minus 4. So 3 squared is 9. 9 times 2 is 18. And 18 minus 4 is going to give me 14. Okay, so now I know I've got this point 3 comma 14, and I've got a slope of 12. So using point slope form, I can write y minus y1 equals mx minus x1, and I'm going to replace the x1 with 3. I'm going to replace the y value with 14. And I'm going to replace my slope with 12. That is a 12. And then I could do distributive property with that 12, and I get this, add 14 on both sides, and now I've got my equation of my tangent line. If I wanted to write it in standard form, I would bring the y to this side. But regardless, there is my equation of this straight line right here. Okay? At this point at 3 comma 14. Okay, so a tangent line touches the curve at one point. Okay, now the next part. Find the equation of a normal to a graph. Okay, so here is my equation at this point 1 comma 4. So the first thing I did was redraw the curve, and so I needed to find the derivative of this. So using the power rule, the power is decreased by 1, and it gets multiplied. So the 2 times 3 gives me 6. The power decreases by 1. So there's my derivative function. I'm going to plug in 1 in place of x, and then I'm going to get a slope of 2. Now you may recall that when you want to find a normal line, I need the perpendicular slope. So if my slope is 2, my perpendicular slope is going to be equal to negative 1/2. Okay, so I'm going to replace m. Okay, well, if you wanted to find the tangent line, you would do this. Okay, my slope of 2, my point of 1, 4. This is the tangent line. Okay, but we wanted to find our normal line. So I'm going to use the slope of negative 1/2. Okay, and we're going to use the x value of 1 and the y value of 4. and rearrange the equation, and now I've got my normal equation. Now this grid was not to scale, so my line should be something. It should be something like this, because of this scale, the 50/40. This is a way compressed here. So, well, next year when I teach this, I'll reprint it with the scale working. But anyways, don't pay attention to that. Okay, so there's my equation of the normal. It didn't ask you to find the tangent equation, but there's my equation for the normal. Okay. Investigation 2. Okay, find the derivative. Once again, we're using the power rule. So here is the derivative. I'm sorry, here is the function. And if you do (3x cubed plus 3x squared minus 4x plus 2. Okay, and just like before, you can do second trace and the minimum and maximum and get these points here. Okay, I won't go into that because you should already know how to find the minimum and maximum points. Okay, and then if I graph the derivative, if I did this graph, it would look something like this. So the important thing to notice is at the maximum here, at negative 1.8, you're going to find that this here is at negative 1.8 comma 0. And at this value here, at this minimum value of 0.412, this x value is going to be 0.12 comma 0. Okay, so the important features that you should get to know is, so if I've got my function, so there is a minimum and a maximum, and I would call these a local minimum and a local maximum. And then, so the feature of the derivative shows you, so if I did a sign diagram when I look at my derivative function, to the left of negative 1.8, we have positive values. It's above the x-axis. To the right, it's negative. So if I go from positive to negative, I'm going to be at a maximum. On my derivative function, if I go from a negative to a positive, then we're going to have a minimum. So I can figure that out from the derivative. So that helps us figure out whether it's a maximum or minimum. Okay, if I look at question 6, if the domain is restricted to negative 2 and 2, find the actual maximum and minimum. So if I plug in negative 2 into my function, I end up with negative 2. So if I plug in negative 2 in here, then I end up with negative 2. Okay. So if I plug in negative 2, I end up with negative 2. If I plug in positive 2, we end up with 30. So the actual maximum is 30. The actual minimum is, you can't see what I'm doing. So the actual minimum is negative 2. The actual maximum is 30. So what we did here was we found the local minimums and local maximums. And this is probably what they're going to ask you on an IB test or something. Question 7, on a function with restricted domain, where might the maximum and minimums occur? So in this example, the maximum and minimums occurred at the negative 2 and the 2. Okay. And how can you use the derivative to find a local maximum or minimum? So the local maximum and minimum happen when the derivative is 0. Okay, and the next part, investigation 3, is our new lesson, taking the derivative using the chain rule. Okay, so let's do this right now. Okay, so I've got 2x squared minus 5 squared. So I could rewrite this as 2x squared minus 5 times 2x squared minus 5. And if I FOIL it out, 2x squared times 2x squared gives me this. 2x squared times negative 5 gives me this. Negative 5 times 2x squared gives me this. And negative 5 times negative 5 gives me positive 25. Combine the middle terms, and we end up with 16x. We end up with 20x to the fourth minus 20x squared plus 25. So if I take the derivative, we end up with 16x cubed minus 40x. Okay, so now we're going to write this as a composite function. So I'm going to let u equal 2x squared minus 5. So if I'm letting u be 2x squared minus 5, instead of saying y equals 2x squared minus 5 squared, I'm going to say, instead of writing this squared, I'm just going to write u squared, where u equals 2x squared minus 5. And so now I'm going to take the derivative of y equals u. So the 2 comes to the front. We end up, the derivative is going to be 2u. If I take the derivative of u, I'm going to end up with, using the power law, 2 times 2, that's going to give me 4, and this x squared becomes x. Okay, and now we're going to do something called the chain rule. So the chain rule says I can have the derivative of dy du times the derivative of du dx. So basically, the 2 times u, 2u, and then times 4x. Okay, and now I'm going to substitute, I'm going to replace u with my 2x squared minus 5. So now I've got 2 times u, which is 2x squared minus 5, times 4 times x. Okay, now I can do some multiplication. 2 times 4 is going to give me 8, so I've got really 8x here, times this yellow stuff. And then if I distribute some further, then I end up with 16x cubed minus 40x. And what we did up here, when I took the derivative, we ended up with 16x cubed minus 40x. So I just showed you here that this is going to give us, the two answers are going to be the same. So the rest of this handout is going to be about chain rule, but since the bell just rang, I will finish this video during third period.